Hey there, Seahawks, it's Miss Adams, and in this video, we're going to talk about measuring variability. All right, so range takes the largest number in our data set and subtracts the smallest number in the set to give us the difference between these two extremes. The larger the range, the more spread out the data is. All right, so find the range. The sample of starting salaries in thousands of dollars. All right, so we got to find the largest number and the smallest number, and we're going to subtract maximum minus minimum. So we get 10. So remember, this is in thousands of dollars, so the sample has a range of $10,000. Interquartile range doesn't consider extreme values. The IQR looks at the range of the middle 50% of the data. Right? So find the interquartile range. All right, so first thing we're going to do is put our data in order from least to greatest. Then we're going to go ahead and find the center. So it's between those 41 values. And then I'm going to find the middle value on the left side. That's quartile 1. The middle value on the right side, that'll be quartile 3. The median is actually called quartile 2, but we mostly just refer to it as the median. And then we are going to find the interquartile range, which is Q3 minus Q1. So 44 minus 39, which is 5. So the IQR would be $5,000. Variance is the average of the squared differences from the mean. A small variance indicates that the data points tend to be very close to the mean and each other. One problem with variance is that it does not have the same unit of measure as the original data. Standard deviation is the average amount we expect a point to vary or deviate from the mean. This is the square root of the variance. All right, so there's two formulas there for the sample standard deviation, where I'm using x bar, the sample mean, and the population standard deviation, where I'm using mu, the population mean. Notice that with the sample mean, we're dividing by n minus 1 to kind of give us some like degrees of freedom just in case. And then in the population, we're dividing by capital N, which stands for the population size. Most of the time, we'll be using the sample standard deviation. All right, so to find the standard deviation, we first need to find the mean. Then we need to find the deviation. We got to square that deviation, add up all the deviations, divide by n minus 1, and take the square root. All right, so we're going to make a table. We're going to start with our value. Then we're going to subtract the mean. How much does it deviate from the mean? We're going to get that difference, and we're going to square that difference. All right, so here were my values. My mean, I added up all my values, divided by how many I had, was 41.5. So I'm going to subtract 41.5 from all of those values, and I'm going to find the difference. So 37 minus 41.5 is negative 4.5. 38 minus 41.5 is negative 3.5. So I'm going to subtract and find those differences. And then when the number is smaller than the mean, it's going to be negative. When the value is larger than the mean, I'm going to get a positive difference. All right, so I'm going to square those so that those negatives don't really have any sort of impact. So I'm going to square all of the differences, taking that difference, multiplying it by itself, negative 4.5 times negative 4.5. Okay, now that I have all of the differences squared, so I took the value, I subtracted the mean, gave me the difference, I squared it. Now I'm going to add up all of those squared differences, which gives me 88.5. Then I'm going to take those squared differences and I'm going to divide by n minus 1. Well, I had 10 values, so 10 minus 1 would be 9, which gives me 9.833. And to get the standard deviation, that would be the variance. To get the standard deviation, I'm going to take the square root, and I get 3.136. All right, symbols for variance and standard deviation. So population values, we're going to use different symbols when we're working with the population versus when we're working with a sample. So for the mean, we use mu for population, x bar for sample. Variance would be sigma squared for population, or s squared for sample. Standard deviation is sigma, and for the sample is s. The number of entries, like your population size, is capital N if it's the population, lowercase n for the sample. The deviation is your value minus the mean, so x minus mu for the population, x minus x bar for the sample, and then the sum of the squares, so the sum of the squared differences, the summation sign tells you to add each of those differences up, and we're the squared differences. All right, when to use each measure of spread. If a distribution is symmetric or approximately normal, we're going to use the standard deviation. If it's skewed to the left or skewed to the right with outliers, we're going to use the interquartile range. All right, to get the standard deviation on the calculator, because you're not going to want to go through that process every time, you're going to go to Stat, Edit, and you're going to enter your data into List 1. Then you're going to go to Stat, Calc, 1 var stats, and you're going to use List 1 to calculate. And you hit Calculate. SX is your standard deviation, is what it shows up on your calculator. So use your graphing calculator to find the mean, the standard deviation, the range, and the IQR. All right, so we'll do a lot of practice with this in class, but we're going to go to Stat, Edit, and we're going to enter all of these values into List 1. All right, once you have them in, you're going to go to Stat, go over to Calc, 1 var stats, and you're doing this for List 1, and you should get mean, x bar, is 8.07, SX, the standard deviation, is 4.21. The range, it doesn't give you, but if you scroll down, you'll get the maximum and the minimum, and the range is max minus min, so 15 minus 1 is 14. IQR, it doesn't give you, but it gives you quartile 3 and quartile 1. IQR is Q3 minus Q1, so we just subtract those and we get 8. All right, here's another one. So go ahead, maybe pause and try in your calculator and see if you can get the mean, standard deviation, range, and IQR. All right, so you should have gotten a mean of 277.89, a standard deviation of 26.12, a range 312 minus 235, which is 77, IQR 299.5 minus 253, which gives me 46.5. All right, go Seahawks.